Welcome to MindTier Learning, where we make GCSE learning and revision simple. Today, we'll explore effective strategies to help you understand and retain key information, making your study time more productive and less stressful. Let's dive in and uncover some practical tips to boost your confidence and success in your GCSE exams. In this lesson, we are moving away from the steep, narrow upper course and into the middle section of a river's journey. By the time a river reaches the middle course, it has usually grown larger. More tributaries have joined it, so it carries more water. The valley is wider, the gradient is gentler, and the river has more energy to move sideways across the landscape. The key process in the middle course is lateral erosion. Lateral erosion means sideways erosion. Instead of mainly cutting down into the landscape, the river begins to cut sideways. This creates wide bends called meanders and, eventually, features called oxbow lakes. Today we are going to look at why rivers bend, how meanders form, what happens on the inside and outside of a bend, and how oxbow lakes are created when a meander is cut off. The big question for today is, why does a river in the middle course start to curve and shift across the valley floor? Let's begin with the learning objectives. By the end of this lesson, you should be able to do 4 things. First, you should be able to explain how helicoidal flow and pools and riffles lead to meander formation. That sounds complicated, but we will break it down. Helicoidal flow is a corkscrew-like movement of water. Pools are deeper sections of the riverbed, and riffles are shallower, pebbly sections. Together, these features help push water from side to side, starting bends in the channel. Second, you should be able to analyze the cross-section of a meander, including river cliffs and slip-off slopes. This means you need to understand what happens on the outside bend and inside bend of a river. Third, you should be able to sequence the stages of oxbow lake formation. This is a common GCSE exam topic. You need to know the correct order. Erosion narrows the neck, the river breaks through, deposition seals the old loop, and an oxbow lake is left behind. Finally, you should be able to evaluate why lateral erosion becomes the dominant process in the middle course. This means explaining why rivers stop mainly cutting downwards and start cutting sideways. So, by the end of the lesson, you should understand that the middle course is not still or fixed. It is a zone of movement, erosion, deposition, and constant change. Before we go further, let's look at the key vocabulary. The first word is meander. A meander is a pronounced bend or curve in a river's course. Meanders are one of the most recognizable features of the middle course. The second word is thalweg. The thalweg is the line of fastest flow in the river channel. It is where the water has the greatest velocity. In a meander, the thalweg is usually found near the outside of the bend. The third term is point bar. A point bar is a beach-like deposit of silt, sand, or pebbles on the inside of a bend. It forms where the river has less energy and deposits material. At GCSE, you may also hear this called a slip-off slope. The final key term is oxbow lake. An oxbow lake is a U-shaped or crescent-shaped body of water formed when a wide meander is cut off from the main river channel. These words are very important because they allow us to explain landforms accurately. In GCSE Geography, using key terms well can make your answer much stronger. Before we focus on the middle course, let's quickly recap the upper course. In the upper course, the river is close to its source. The land is usually steep, the channel is narrow, and the river has lots of energy to erode downwards. The main type of erosion in the upper course is vertical erosion. Vertical erosion means the river cuts down into the landscape. This creates features such as V-shaped valleys, interlocking spurs, waterfalls, and gorges. One important upper course landform is a waterfall. Waterfalls often form where a river flows over bands of hard and soft rock. The soft rock is eroded more quickly than the hard rock. Over time, the soft rock underneath is undercut, leaving an overhang of hard rock. Eventually, the overhang collapses. The fallen rock helps deepen the plunge pool through abrasion and hydraulic action. This process repeats, causing the waterfall to retreat upstream. As we move downstream, the gradient becomes gentler. The river has more water and begins to use more of its energy to erode sideways. That is when lateral erosion becomes more important. Let's check your recall from the upper course. The question is, what is the primary cause of a waterfall's retreat upstream? Is it 1. The river runs out of energy in the mountains? 2. Undercutting of soft rock leads to the collapse of the hard cap rock. 3. The river starts to erode laterally instead of vertically. 4. Deposition of sediment fills the plunge pool. Take a moment to decide. Remember, the question is asking why the waterfall moves backwards over time. Think about the role of hard rock, soft rock, undercutting, and collapse. The correct answer is 2. Undercutting of soft rock leads to the collapse of the hard cap rock. This happens because the softer rock underneath is eroded more quickly. As it is worn away, the hard rock above is left unsupported. Eventually, it collapses into the plunge pool. The collapsed material is then used by the river as tools for erosion, which helps deepen the plunge pool further. Over time, this process repeats and the waterfall retreats upstream. This is important because it reminds us that rivers change landscapes through erosion. But in the middle course, the direction of that erosion changes. Instead of mainly cutting downwards, the river starts to erode sideways. Now let's ask an important question. Why don't rivers just flow in a straight line? It might seem logical that water should take the simplest route downhill. But in reality, rivers rarely flow in perfectly straight lines. Even in a fairly straight channel, water does not move evenly. It often moves in a corkscrew-like pattern called helicoidal flow. This means the current twists through the channel, pushing water from side to side. The riverbed is also uneven. It often contains alternating deep and shallow sections. The deeper sections are called pools. The shallower, pebbly sections are called riffles. As water moves over this uneven bed, it is deflected from one side of the channel to the other. This creates tiny bends at first. Over time, these bends become larger as erosion and deposition exaggerate the curve. So meanders begin because the river's flow is uneven. Once a slight bend forms, the processes of erosion and deposition make the bend more pronounced. Now we are going to look at the structure, or anatomy, of a meander. A meander has two very different sides, the outer bend and the inner bend. Let's start with the outer bend. On the outside of the bend, the water is deeper and faster. The thalweg, or fastest flow, is pushed towards the outer bank. This gives the river more energy to erode. Two important erosion processes happen here. The first is hydraulic action. This is when the force of the water hits the river bank and breaks material away. The second is abrasion. This is when sediment carried by the river scrapes and wears away the bank, a bit like sandpaper. These processes create a steep bank called a river cliff. Now let's look at the inner bend. On the inside of the bend, the water is shallower and slower. Because it has less energy, the river deposits material such as silt, sand, and pebbles. This creates a gently sloping feature called a slip-off slope or point bar. So the key contrast is outer bend, fast water, high energy, erosion, river cliff. Inner bend, slow water, low energy, deposition, slip-off slope. Now let's test your understanding. The statement says, the thalweg, or fastest flow, is found on the inside of a river bend. Is that true or false? Take a moment to think. Remember, the thalweg is the line of fastest flow. Where is the water moving fastest in a meander? Is it on the inner bend, where the water is slower and deposition happens? Or is it on the outer bend, where erosion creates a river cliff? The statement is false. The thalweg is not found on the inside of a river bend. It is usually found closer to the outside of the bend. This happens because the fastest water is pushed towards the outer bank. This increases energy and velocity on the outside of the meander. As a result, erosion is strongest on the outer bend. On the inner bend, the water is slower. Because it has less energy, it deposits sediment. So if you are looking at a meander cross-section, remember, the outside bend has the fastest flow and the most erosion. The inside bend has slower flow and more deposition. The correct explanation is B. Centrifugal force pushes the fastest water to the outer bank, increasing erosion there. This is why river cliffs form on the outside of bends. The other option is incorrect because it says friction is highest on the outer bank and causes deposition. In reality, the outer bend has faster, deeper water and more erosion. A strong GCSE explanation might say, in a meander, the fastest flow is pushed towards the outside bend. This increases erosion by hydraulic action and abrasion, creating a steep river cliff. On the inside bend, the water is slower and has less energy, so deposition forms a slip-off slope. That is a strong answer because it names the processes, explains the contrast, and links each side of the bend to a specific landform. Now we are going to look at what happens when meanders become very large. As a river flows through a meander, erosion continues on the outside bends. At the same time, deposition continues on the inside bends. Over time, the meander migrates across the valley floor. The bend becomes wider and more exaggerated. Eventually, the two outer bends of a meander loop can get closer and closer together. The narrow piece of land between them is called the neck of the meander. As erosion continues on both sides, the neck becomes narrower. This is an important stage in the formation of an oxbow lake. During normal flow, the river may still follow the curved path around the meander. But during a flood, the river has more water and more energy. It may take the shortest route by cutting straight through the narrow neck. This creates a new, straighter river channel. Once that happens, the old meander loop begins to be abandoned. Now let's look at the full process of oxbow lake formation. An oxbow lake forms when a meander is cut off from the main river. First, erosion occurs on the outer bends of the meander. Hydraulic action and abrasion wear away the river banks. This makes the neck of the meander narrower over time. Second, during a period of high discharge, such as a flood, the river cuts through the neck. High discharge means the river has more water than usual, so it has more energy. The river then begins to flow along a new, straighter channel. Third, the old meander loop now has slower water. Because the water is no longer flowing strongly through it, deposition begins to occur near the entrances to the old loop. Fourth, sediment builds up and seals off the old meander from the main channel. The result is a separate crescent-shaped body of water called an oxbow lake. Over time, the oxbow lake may fill with sediment and vegetation. Eventually, it may dry up, leaving behind a curved scar on the floodplain. So an oxbow lake is like a footprint of where the river used to flow. In the middle course, the shape of the valley changes. In the upper course, the valley is often narrow and V-shaped because vertical erosion is dominant. But in the middle course, the gradient is gentler and the river starts to erode sideways. This creates a much wider valley floor. Meanders swing from side to side across the landscape. As they migrate, they erode the valley sides and widen the valley floor. The presentation describes this as being like a giant scythe. That is a useful image. A scythe sweeps from side to side, cutting as it moves. In a similar way, the river sweeps across the valley floor, eroding the land and reshaping it. This process helps create the flat land beside the river that later becomes a floodplain. So the middle course is important because it prepares the landscape for the lower course. The river is not just flowing through the valley. It is actively shaping and widening the valley. Now let's test whether you can sequence the stages of oxbow lake formation. The task is to put these stages in the correct order. Deposition seals off the ends of the old loop. An oxbow lake is formed as a separate body of water. Erosion narrows the neck of the meander. The river breaks through the neck during a flood. Think carefully about cause and effect. What has to happen first? Before a river can break through the neck has to become narrow. That happens because of erosion on the outer bends. Then, during a flood, the river cuts through the narrow neck. After that, deposition seals the old loop. Finally, the old loop is completely separated from the main river and becomes an oxbow lake. The correct order is: first, erosion narrows the neck of the meander. Second, the river breaks through the neck during a flood. Third, deposition seals off the ends of the old loop. Fourth, an oxbow lake is formed as a separate body of water. This is a really important sequence to remember for GCSE exams. A strong written answer might sound like this. An oxbow lake forms when erosion on the outer bends of a meander narrows the neck. During a flood, the river has more energy and cuts through the neck, creating a straighter channel. Deposition then occurs at the entrances to the old meander loop, sealing it off from the main river. The abandoned loop becomes a crescent-shaped oxbow lake. That answer would be strong because it explains the sequence clearly and uses geographical vocabulary. Now let's apply this to a bigger geographical issue. The question is, how would a significant increase in river discharge, for example, because climate change causes more heavy storms, affect the rate of oxbow lake formation in the middle course? This is asking you to think beyond the basic process. Discharge is the amount of water flowing in a river. If discharge increases, the river usually has more energy. With more energy, the river can erode more quickly. This means the outer bends of meanders may be eroded faster. If outer bends erode faster, the neck of the meander may narrow more quickly. Heavy storms and floods can also trigger breakthrough events. During a flood, the river may take the shortest route and cut through the neck of a meander. So, if heavy storms become more frequent, oxbow lakes may form more quickly in some river systems. However, a strong answer should also be balanced. Not every river will respond in exactly the same way. The rate of oxbow lake formation also depends on the type of rock, the amount of sediment, the shape of the valley, vegetation, flood management, and human interference. But overall, more frequent high discharge events could increase erosion, increase the chance of meander cutoffs, and speed up the formation of oxbow lakes. You might have said that increased discharge gives the river more energy for erosion. That is correct. More energy means more hydraulic action and abrasion on the outer bends. This can narrow meander necks more quickly. You might also have said that heavy storms can trigger breakthroughs. That is also correct. During a flood, the river may cut through the narrow neck of a meander and form a new, straighter channel. You might have added that oxbow lakes could form and dry up faster than in the past. That is a strong point because it recognizes that river landscapes are dynamic. They change over time, and the rate of change can increase if river conditions become more extreme. A strong answer could say, an increase in discharge would give the river more energy, increasing erosion on the outer bends of meanders. This would narrow the neck of the meander more quickly. During floods, the river may cut through the neck and create a straighter channel. Deposition would then seal off the old loop, so oxbow lakes could form more rapidly. That kind of answer links discharge, erosion, breakthrough, deposition, and landform formation. Let's finish by reviewing the key ideas from today's lesson. The middle course is a place of constant change. As the river moves downstream, the gradient becomes gentler and the river begins to erode sideways rather than mainly downwards. This sideways erosion is called lateral erosion. Meanders begin because river flow is uneven. Helicoidal flow, pools and riffles help push the current from side to side. Once a bend forms, the river process is exaggerated. On the outside bend, the water is faster and deeper. This causes erosion by hydraulic action and abrasion, creating a river cliff. On the inside bend, the water is slower and shallower. This causes deposition, creating a slip-off slope or point bar. Over time, erosion on outer bends causes the meander neck to narrow. During a flood, the river may cut through the neck and take a straighter route. Deposition then seals off the old loop, forming an oxbow lake. The biggest takeaway is this. The middle course is shaped by the balance between erosion and deposition. Erosion on the outside of bends and deposition on the inside cause the river to migrate across the valley floor. Over time, this widens the valley and leaves behind oxbow lakes as evidence of the river's former path. Thank you all for watching. If you found this presentation helpful, please remember to like the video and subscribe to our channel. Your support really helps us continue to create valuable content for you. See you next time.